Welcome to True Projects. In this video, we are going to explain about the project title, an efficient data mining technique for assessing satisfaction level with online learning for higher education students during the COVID-19. Introduction. The COVID-19 pandemic drastically disrupted conventional education systems, leading to the widespread closure of educational institutions and the implementation of lockdowns in many countries. Higher education institutions were significantly affected, necessitating the exploration and adoption of alternative solutions to ensure continuity in education. Given the restrictions on physical gatherings and the need for social distancing, online learning emerged as a viable alternative for students to continue their education remotely. Online learning allows students to access educational materials, interact with instructors, and collaborate with peers using various digital devices and an internet connection. This shift to online platforms became essential to ensure the safety and continued learning of students during the pandemic. Assessing student satisfaction level (SSL) is vital to evaluate the effectiveness and quality of online education. It helps understand how well students are adapting to online learning platforms and whether their educational needs and expectations are being met. Educational data mining (EDM) involves applying data mining techniques to educational data, enabling the extraction of valuable insights to improve the educational process. In this project, EDM is utilized to analyze data related to students' interactions, behavior, and performance in the online learning environment. Objective. The primary objective of this project is to assess the satisfaction level of higher education students with online learning during the COVID-19 pandemic. This assessment is conducted through the application of educational data mining (EDM) techniques. EDM involves applying data mining methods and principles to educational data, aiming to extract valuable patterns, trends, and insights that can aid in understanding and improving the educational process. In this context, EDM is specifically employed to analyze data related to student satisfaction with online learning experiences during the pandemic. The project aims to leverage data mining (DM) concepts and techniques to extract valuable and relevant information regarding student satisfaction levels (SSL) with online learning. DM involves the process of discovering patterns and insights within large datasets, and in this project, it's employed to derive meaningful information from the data related to students' perception and experiences with online education during the COVID-19 lockdown. One of the key focuses of the project is the application of feature selection (FS) techniques. FS involves identifying the most relevant subset of features from a dataset while minimizing the cardinality number of features. In this context, FS is crucial because it significantly influences the predictive accuracy of the satisfaction model. By selecting the most pertinent features, the model can be fine-tuned to better predict and understand the factors that influence student satisfaction with online learning, ultimately aiding in making informed decisions to enhance the quality of online education during the pandemic. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. Importing refers to bringing in external libraries or modules into the project environment. These libraries contain pre-built functions and methods that simplify various tasks. In this case, importing packages involve bringing in libraries like Pandas for data manipulation, NumPy for numerical operations, Seaborn and Matplotlib for data visualization, and scikit-learn for machine learning tasks. These packages provide efficient tools for handling data and visualizing patterns, which are crucial for data mining and analysis. Exploring the dataset. This step involves understanding the structure and contents of the database. It typically includes tasks like loading the dataset into memory, examining the number of rows and columns, checking for missing or null values, understanding data types, and getting a sense of the data distribution. Exploratory data analysis (EDA) techniques are often applied here to gain insights into the dataset and identify initial patterns or trends. Data processing. Data processing involves preparing the dataset for analysis. This encompasses tasks such as handling missing values, encoding categorical variables, scaling numerical features, and potentially transforming the data to meet the requirements of the selected machine learning algorithms. Pre-processing is a crucial step to ensure that the data is in a suitable format for the subsequent modeling phases. Visualization using Seaborn and Matplotlib. Seaborn and Matplotlib are popular Python libraries used for data visualization. Seaborn is known for creating attractive and informative statistical graphs, while Matplotlib provides a wide range of plotting capabilities. Visualization is crucial for gaining a visual understanding of the data, identifying patterns, trends, and outliers, and communicating findings effectively. Plots and charts are used to represent the data in a visually appealing manner. Data cleaning. Data cleaning involves identifying and addressing issues in the dataset that could affect its quality and the performance of subsequent analysis or models. Tasks in this module include handling missing or erroneous data, removing duplicates, addressing outliers, and ensuring data consistency. Clean, reliable data is essential for accurate analysis and modeling. Splitting the data to train and test. Before building predictive models, it's essential to split the dataset into training and testing sets. The training set is used to train the model, while the testing set, unseen by the model during training, is used to evaluate its performance. Typically, a significant portion of the data is allocated to training, example 80%, and the remainder is used for testing, that is 20%. This split helps in assessing how well the model generalizes to new unseen data. Optimization model. The mentioned optimization models are various nature-inspired and meta-heuristic algorithms that can be employed to enhance the efficiency and effectiveness of data mining in the context of assessing satisfaction levels with online learning for higher education students during the COVID-19 pandemic. Whale Optimization Algorithm (WOA). WOA is a nature-inspired meta-heuristic algorithm inspired by the hunting behavior of humpback whales. It mimics the social behavior of whales to optimize complex functions. In the context of the project, WOA, Whale Optimization Algorithm, is applied to optimize parameters or features relevant to assessing student satisfaction levels in online learning. ABCFS, Artificial Bee Colony with Feature Selection. ABCFS is a hybrid algorithm that combines artificial bee colony ABC algorithm with a feature selection technique. ABC is inspired by the foraging behavior of honeybees and is used for optimization. In this context, ABCFS can be utilized for feature selection to identify the most relevant features associated with student satisfaction in online learning. Atom Search Optimization. Atom Search Optimization is a meta-heuristic algorithm inspired by atomic structures and principles. It mimics the behavior of atoms to explore the search space efficiently. It can be applied in the project to optimize parameters related to online learning satisfaction assessment. SFO, Sailfish Optimizer. SFO is inspired by the hunting behavior of sailfish in the ocean. It is a meta-heuristic algorithm that aims to find the optimal solution by simulating the hunting and encircling behaviors of sailfish. In this project, SFO could be employed to optimize parameters relevant to student satisfaction assessment. QSO, Quantum Search Optimization. QSO is a quantum-inspired optimization algorithm that utilizes principles of quantum computing for optimization purposes. It uses quantum bits and principles like superposition and entanglement. QSO can be applied to optimize the assessment of student satisfaction in online learning by efficiently exploring the solution space. PSO, Particle Swarm Optimization. PSO is a population-based optimization algorithm inspired by the social behavior of birds or fish. It involves particles moving through the search space to find the optimal solution. In this project, PSO is utilized to optimize parameters and features associated with online learning satisfaction assessment. BSA. BSA is a nature-inspired optimization algorithm based on the echolation behavior of bats. It involves random walks and echolation phases. CRO. CRO and NRO are both hyperheuristic algorithms. Grasshopper optimization algorithm. Grasshopper optimization algorithm is inspired by the swarming behavior of grasshoppers. It involves searching for the optimal solution using local and global search strategies. It can be applied to optimize parameters relevant to the assessment of student satisfaction in online learning. EPO. EPO, evolutionary programming, is an evolutionary computation technique inspired by the process of natural selection. It uses mutation and recombination operations to evolve solutions. EPO can be applied to optimize parameters and features related to online learning satisfaction assessment. DE, differential evolution. Differential evolution is a stochastic population-based optimization algorithm. It operates by iteratively improving a candidate solution with respect to a given measure of quality. DE can be used to optimize parameters and features relevant to assessing student satisfaction in online learning. CSO. CSO is crow search algorithm is inspired by the social behavior of crows. It involves exploring the search space based on the locations of crow. It can be applied in the project to optimize parameters related to student satisfaction assessment. BAT algorithm. BAT algorithm is a nature-inspired optimization algorithm based on the echolation behavior of bats. It involves random walks and echolation phases. In the context of the project, BAT algorithm is employed to optimize parameters for assessing student satisfaction levels in online learning. ABFOLS. Advanced Butterfly Optimization Algorithm. ABFOLS is an optimization algorithm inspired by the behavior of butterflies. It involves mimicking the movement and swarming behavior of butterflies to optimize a given objective function. In the context of the project, ABFOLS could be utilized to optimize parameters relevant to online learning satisfaction assessment. Building the model, in which we have different algorithms. The first algorithm which we have used is random forest. Random forest is an ensemble learning method based on decision tree classifiers. It creates a forest of decision trees during training and outputs the class, that is the mode of the classes, from individual trees. It's effective in handling a large number of features and provides good accuracy. In this project, random forest is used to predict student satisfaction levels by analyzing various features and their importance. Decision tree. A decision tree is a tree-like model where each internal node represents a feature, each branch represents a decision rule, and each leaf node represents an outcome. It's a widely used classification technique and can be helpful in this project to create a clear decision-making process based on features related to student satisfaction with online learning. KNN, K nearest neighbor. K nearest neighbor is a simple and widely used classification algorithm. It classifies a data point based on the majority class among its K nearest neighbors in the feature space. KNN is applied in this project to predict student satisfaction levels based on the satisfaction levels of nearby students in the feature space. SVM, Support Vector Machine. SVM is a powerful classification algorithm that aims to find the best hyperplane that separates different classes in the feature space. It's effective in handling both linear and nonlinear data. In this project, SVM can be employed to classify and predict student satisfaction levels based on various features related to online learning. Voting classifier. A voting classifier is an ensemble learning method that aggregates the predictions of multiple Bayes estimators, example, random forest, decision tree, KNN, SVM, and predicts the class label by majority voting. It combines the strengths of different models, potentially resulting in improved overall prediction accuracy. TF, term frequency. Term frequency is a simple yet fundamental technique used in natural language processing (NLP). It represents the frequency of a term word in a document. In the project, TF is utilized to analyze and evaluate the importance of specific terms in student feedback or comments related to online learning. Training the model. This step involves using the provided dataset to train the machine learning model. In this project, a voting classifier is chosen for improved accuracy by combining the predictions of multiple Bayes models, example, random forest, decision tree, KNN, SVM. Training the model involves fitting the data to the classifier, allowing it to learn patterns and relationships between the features and the target variable. Building the model with voting classifier, since it gives better accuracy comparing with other models. The voting classifier is selected as the primary model because it aggregates the predictions of multiple Bayes models, potentially resulting in better accuracy compared to individual models. It combines the strengths of various classifiers to provide a more robust and accurate predictive model. The trained voting classifier becomes a crucial component in the prediction process. Flask framework with SQLite for sign-up and sign-in. Flask is a micro-web framework in Python used for developing web applications. In this project, Flask is utilized to create the backend structure for user sign-up and sign-in. SQLite is a lightweight database management system, is integrated with Flask to handle user authentication, securely storing user data such as usernames and password. User gives input as feature values. The given input is pre-processed for prediction. Users provide input in the form of feature values that are relevant to assessing satisfaction levels with online learning. These features can be aspects like course content, platform usability, interaction with instructors, or any other relevant parameters. The input is collected from the user through the front end and prepared for further processing. Pre-processing involves transforming the user provided input into a format suitable for the prediction model. This includes steps like encoding categorical variables, scaling numerical features, handling missing values, or any other necessary pre-processing steps. The transformed input is then ready for prediction using the trained model. Trained model is used for prediction. The trained voting classifier is utilized to predict the satisfaction level of the user based on the pre-processed input. The model, which has learned from the training data, employs its knowledge to provide an accurate prediction regarding the user satisfaction with online learning. Final outcome is displayed through front end. The prediction outcome, indicating the predicted satisfaction level, is displayed through the front end to the user. This provides valuable information based on the input features provided by the user. The front end serves as the interface through which users can interact with the application and view the results of the prediction. Execution. To execute this project, first we need to open the code folder, which contains the project source code files. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I am typing python space app.py. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now hit enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this, and port, which is this. Now copy this local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The home page of the project is displayed in the browser. This is the front end built using Flask framework. Now click on sign up button. If we are a new user, we need to register first, but I have already registered, so click on sign in button. This is the login form. Here we need to enter the username and the password which we have created. So I'm entering the username and the password, and now click on login. This is the home page of the project. So here we need to enter these details, and after entering these details we will predict the student satisfaction level. So this is the student progress prediction using ML. So I'm filling the details. So here I have entered the details. The gender is female, age is 18 years, mother's education is higher education, father's education is also higher education, mother's job is at home, that is the mother doesn't work, father's job is teacher, reason to join the school is course preference or other, student's guardian is mother, travel time to school is 15 to 30 minutes, weekly study time is 2 to 5 hours, number of failures in past is 0, family relationship very good, free time after school intermediate, outing with friends high, alcohol consumption very low, alcohol consumption weekend very low, health status good, number of days absent 4. Now click on predict. We got the outcome. Student satisfaction level is satisfactory. Now let us enter details of one more student and find the student satisfaction level. So here I am entering details of one more student, that is a male, age is 15 years, mother's education is higher education only, and father's education is secondary or higher, mother's job is civil service, and father's job is other, at home or other, reason to join the school is close to home, student's guardian is a mother, travel time to school is less than 15 minutes, weekly study time is 2 to 5 hours only, number of failures in past is 0, family relationship is excellent, free time after school is intermediate only, outing with friends is low, alcohol consumption workday is low, alcohol consumption weekend is also low, health status is bad, and number of days absent is 0. Health status is actually very good and number of days absent is 0. Now click on predict. So here we can see the student satisfaction level is satisfactory only. Now let us enter details of one more student. So I'm entering the details. So here I have entered the details of one more student. Gender is female, age is 19. Mother's education is higher education, father's education is secondary or higher. Mother's job is a teacher, father's job healthcare related. Reason to join the school is school reputation. Student's guardian is a mother. Travel time to school is 15 to 30 minutes. Weekly study time is 5 to 10 hours. Number of failures in past is 1. Family relationship excellent. Free time after school is intermediate. Outing with friends intermediate. Alcohol consumption workday very low. Alcohol consumption weekend low. Health status is normal. Number of days absent is 10. Now click on predict. So the student satisfaction level is poor. So let us enter one more student details and find the satisfaction level. So I'm entering the details of one more student. So here I have entered the details of one more student. That is, gender is male, age is 18, mother's education none, father's education higher education, mother's job at home, father's job at home or other. Reason to join the school, course preference or other. Student's guardian is mother. Travel time to school is 15 to 30 minutes. Weekly study time is less than 2 hours. Number of failures in past is 0. Family relationship excellent. Free time after school is intermediate. Outing with friends is low. Alcohol consumption workday intermediate. Alcohol consumption weekend intermediate. Health status is good. Number of days absent is 5. Now click on predict. Student satisfaction level is good. So in this way, by entering the details, we can predict the student satisfaction level. The conclusion of the project is, the primary objective of this project is to evaluate and assess the satisfaction levels of higher education students with online learning, specifically during the challenging circumstances of the COVID-19 lockdown. Educational data mining (EDM) is employed as a key methodology for this assessment. EDM involves applying data mining techniques to educational data, enabling the extraction of valuable patterns, trends, and insights to understand and enhance the online learning experience. The project specifically delves into the effectiveness of feature selection, techniques to enhance the predictive accuracy of the satisfaction model. FS involves identifying the most relevant subset of features from the dataset, minimizing the number of features while maximizing the predictive power. The project evaluates various wrapper FS techniques in the context of data mining and classification algorithms like k-nearest neighbor and support vector machine. The project underscores the significance of feature selection in achieving high accuracy prediction of student satisfaction level. By selecting a relevant set of features through FS, the prediction model can focus on the most influential factors that determine student satisfaction. This in turn facilitates the derivation of constructive educational strategies, enabling institutions to tailor their approach and address specific aspects of online learning that significantly impact student satisfaction.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.